You know, 3D printing, additive manufacturing has for years been thought of as a prototyping technology. It's great to make the first of something or maybe even do a functional fit check prototype. When you actually want to manufacture it, you got to go to other systems, but that isn't necessarily the case anymore. I'm with Chris Schneider. He's applications engineer at 3D Systems. And Chris, I understand that 3D Systems, you're thinking of this as on a holistic kind of a basis, from design to manufacturing, and we're talking about production here, not just prototypes these days.
Correct, yep. Today we're showing our end-to-end manufacturing solutions, starting with our design software to additive or subtractive manufacturing, utilizing full-scale printers, as well as following up with our inspection software to make sure you're validating the parts that you're producing.
So Chris, where does the process start?
Okay, so our process starts either at a CAD package or a design package. So we produce a scan-based design software to either scan a part and create a fixture or an additional part in the assembly, or some sort of simulation package to optimize your part for additive manufacturing that can't be produced another way. Mm-hmm. And then you can produce your part on any of our printers, either metal or plastic printing.
Mm-hmm. Now, additive lets you iterate in ways you never could before because it's relatively cheap. So I can make 15 versions of something and test them all to see what works best. That's not usually the best way to do it. What tips or tricks for designers that are used to subtractive manufacturing, how do they have to change their mindset when designing something for additive?
Yeah, so the sky's the limit with additive manufacturing. So we utilize a lot of analysis software to apply pressures and forces to our models, and they can be changed any way. So we're not limited to having to fix a model and then machine it away. Mm-hmm. We can just build in any orientation and any geometry that we possibly can imagine, and then produce the part kind of overnight until we can test it and then check and see what we need.
Yeah, it's interesting. Now, most designers are used to conventional manufacturing tend to think in Cartesian kinds of ways. You think about a primary axis, you think about how we hold something with a work holding solution, how we turn it, how we mill it. But you could actually build things upside down, inside out. This has to be. How do you hold it? How do you get the support structure inside? Is that sort of a black art, or is that something you can?
Yeah. So we have two software that are optimizing that entire process. Mm-hmm. So we have 3D Sprint for our plastic machines, and they optimize based on the technology. So some of the metal technology needs to be supported from the underside, and the other ones need to be held down onto the build tray. So 3D Sprint does that specifically for our plastic machines, and then we have our 3D Expert software that does a great job on our metal machines. So it also does FEA analysis on the parts themselves, so the part that you get is actually true to CAD rather than just the part that gets sent out of the printer.
Now, we think of the build envelope, the build volume, in that 2D world, for example, the sheet metal people live in, they use software to optimize nesting so they can get the maximum number of parts out of a single sheet of metal. Yeah. In the 3D world, you actually have a build envelope at this point. Can you nest components and make multiples and maximize it the same way?
Yes, we optimize both in 2D and in 3D space. So when we're looking for the fastest sprint times, we optimize it so it's the shortest amount of distance from the base of the build tray and nest as tight as possible. But when we don't care and we want to do the entire thing, we want to produce the most amount of parts possible, we can do 3D nesting. So if we have voids and holes in our parts, we can actually fit additional parts inside other parts to get the most of our time on the machine.
Mm-hmm. And materials. There was a time when materials were highly limited. Mm-hmm. You could do, say, for a functional part for fit check or something, but you're making a PMMA or some material which is far from what a production part would be. Can we really get to a point now where you can make parts that are truly representative of what a production part will be?
Yes, we have a large range of plastic materials, from elastic to very hard rigid plastics, to high temperature plastics, all kinds of possible plastics we can use to produce any kind of part that you would make, either injection molded or something like that. Mm-hmm. And then we have an open metal system that you can put any metal powder you would like. So we provide a lot of parameters and materials there. We let you do anything that if you want to do some research and testing, you can do any material that you'd like.
Okay, so end user could actually work on developing a custom material as necessary?
Yep, correct.
Okay.
And we provide the software that lets you build that custom material part the way you want it.
Yeah. If there's one piece of advice you could give to a subtractive manufacturer now who wants to take the leap, but they're not quite sure what to do, is what mistake could they avoid, or what favor could they do themselves before they approach you?
I would say just try something, right? The sky's the limit. We can probably do anything that you can make. So do something once that you think we probably can't do, and then go one step farther. All right, let us surprise you, and we'll give you the best that we got.